about input-output organization. So input-output organization. What is the use of input-output organization? That is, we have to transfer the data between the I/O devices and the processor. Actually, we have to transfer the data between the processor, memory, and the I/O devices. For that, we go for I/O organization. Okay. Our aim is to transfer the data among the processor, memory, and the I/O devices. For that, we need a interconnection network. That network is called a bus. So we need a network to transfer the data between the processor, memory, and the I/O devices. So for that, we need a network, and that network is called a bus. Okay, we'll see the bus structure. See, as I said, we have to transfer the data between the processor and the I/O device. So we have to transfer the data to the processor. So via the memory, we will be transferring the data. We can connect more than one I/O device to the processor. And the work of the bus is to transfer the data between these units. Okay, we can connect more than one device to other processor. And with the help of the uh, lines, that is, we have bus lines to carry the address, the data, and the control signal. So we have three bus lines, one to carry the address, another to carry the data, and third one to carry the control signal. And what is this address? So in the previous classes, we have seen the address is nothing but the place where we will be storing the data in the memory. So here we say the address not only for the memory but also for the I/O device. Each and every I/O device have an address. So to identify that device, we have an address. Okay. So there is a bus line to carry the address and the data. So whatever data the processor wants to get from the I/O device, or if it wants to send the data to the I/O device, it has to send through that line. That is a data line called a data bus. And third one is called the control signal bus. So it carries the control signal. Control signal in the sense whether we are going to read the data or whether we are going to write the data. That is read signal or write signal. That will be carried by the control bus. So we have three bus lines. One is a address line, a data line, and the control line. Address bus, it carries the address. So here we are connecting the I/O device, so it carries the device address. The second one is the data bus. So the data bus carries the data. So when the processor wants to send the data to the printer, the data bus will carry the data to the printer. In the same way, when the processor wants to read the data from the keyboard, the data will be transferred through the data bus to the processor. So the necessary control signals will be carried by the control bus. So we have three address lines. As I said, see here, each and every I/O device will have a unique address. To access the I/O device, what the processor has to do? The processor, it should place the address on the address bus so that any one of the I/O device, it will recognize its address and it will respond to the processor. And while accessing the I/O devices, the memory may be shared. The same memory space can be used by the I/O device. Okay, so that is called memory mapped I/O. When the I/O device and the memory shares the same address space, it is called memory mapped I/O. Okay, the address is equally shared by the memory and the I/O device. That is called memory mapped I/O. So the other cases, it may not be shared. So if it shares, what happens, and if it does not share, what happens, we'll see. So if the I/O device and memory share the same address space, it is called memory mapped I/O, and any machine instruction that can access the memory can be used to transfer the data to or from the I/O device. So when an instruction wants to access the memory, it can use that address to transfer the data to and from the I/O device. And if the I/O device and the memory does not share the same address space, what we have to do? We have to give some special instruction to transfer the data to and from the I/O device. And we'll have a fewer address lines. And also the address line need not be physically separate from the memory address lines. And also, in fact, address lines may be shared between the I/O device and the memory. So with a control signal to indicate whether it is a memory address or an I/O address, we have to indicate that. So this is how we access the I/O device. This is the internal structure, that is input device. It will be connected to the processor via the bus lines. As I said, we have three bus lines: address lines, data lines, and the control lines. And between the IO device and the bus, we have an IO interface. This IO interface, it consists of three registers. One is called the address decoder, another one is a control unit, and the third one is a data and status register. Okay, so these three are the IO interface. So the IO device, it is connected to the bus using the IO interface circuit. Okay, the IO interface, it consists of the address decoder, control circuit, and data and the status register. So the address decoder, what it does is it decodes the address placed on the address lines. So who will place the address on the address line? The processor will place the address on the address line. So the address is nothing but the IO device address. So this address decoder, what it does is it decodes the address, and so that with that we can identify the particular IO device. The data register, it holds the data being transferred to the to or from the processor. Okay. And the status register, it holds the information necessary for the operation of the IO device. That is, when the data is ready in the data register, the status register will say the data is ready. See, when a processor wants to read the data from the input device, what it does is there will be several input devices connected. So the processor, it will place the address of the device on the address bus, and it will make the control lines enable. That is, enable in the sense it will provide a read control signal. That is, it wants to fetch the data from the IO device, and it provides the address. This address is nothing but the device address. Okay, the address decoder, on getting the address from the address line, see the decoder, it gets the address from the address line. So what it does is it will decode the address so that a particular input device will be identified. Okay, so the control lines, it will provide the read control signal. So it will be sent to the control circuit, and it provides the fetch operation to the IO device. Okay, so and the particular input device will be identified, and the device, it will send the data. So it will send the data to the data register. So the data register is along with the status register. When the data is loaded into the data register, the status register is set to 1. So what it does is it says the data is ready, so that the processor will fetch the data from the data register. How it fetches? The data will be sent to the data lines in the bus. So from the data lines, the processor will take the data from the data bus. So there is another thing we have seen, memory mapped IO. That is, when the IO device and the memory shares the same address space, it is memory mapped IO. There is another concept called program controlled IO. So in the previous classes, we have seen that the transfer of data between the IO device and the processor is very slow. That is, the process speed is very high and the IO device speed is very low. So we cannot compensate the speed of the processor and the IO device. So in order, we know that. So in order to avoid that, we go for this program controlled IO. So what it does is the processor, it will repeatedly monitor a status flag. That is, the processor will make a it will place the address in the address bus, and it will give a control signal that it wants to read the data from the data bus, and it will again and again it will monitor the status flag. The status flag says when the data is ready to access, it will make the flag. It will enable the flag to 1, so that the processor, it may do some other work, and each and again and again repeatedly it will monitor the flag. So when the flag is 1, immediately it will get the data. Okay, so that is called program controlled IO. In order to compensate the speed of the processor and the IO device, we have this facility. The another way it can get the data is processor can poll the IO device. It will poll again and again, it will search, and if the data is ready, immediately it will get the data. So next we'll see detailed about the buses. As I said, the network connection between the processor, memory, and the IO device is the bus. It is used to transfer the data among the bus is used to transfer the data among the processor, memory, and the IO device. So as I said, processor, main memory, and the IO devices are connected by means of the bus. So the bus provides a communication path for transferring the data. So we have a protocol called bus protocol. It is a set of rules that govern the behavior of various devices connected to the bus. as to when to place information on the bus, when to assert the control signal. So these are the protocol. Protocol is nothing but so we have this set of rules to govern the behavior of the various devices. So as I said, we have three types of bus: data bus, address bus, and the control bus. So what will be the control signals? The control signal is whether we have to read the data or we have to write the data. And the required size of data and when the several operand sizes are also can be given as a control signal. And then timing information, when that is to indicate when the processor and the IO device may place the data or the processor may receive the data from the bus. So control signals are nothing but we can provide the read or write operation, and also we can specify the size of the data, and also to indicate the timing information when the data can be retrieved. And there are two schemes for data transfers over bus. One is called synchronous and another one is called asynchronous. As I said, synchronous will have a clock pulse. In both synchronous and asynchronous, we have the clock pulses, but in synchronous, we'll be knowing when a particular operation is to be taken place.
Okay. So thank you for listening.